Recording again. Okay, so let me keep going. All right. So I know I did just by mistake erase the underlined stuff. Well, yeah, let me just put it back in. So here we got the area to the left to be this. That's what we got. But again, we wanted the area to the right. So to get the area to the right, you do 1 minus this. That's really what I'm trying to say. All right. Let's do another example. Let's assume now that, again, we have these test scores, okay? The data from these test scores, right? You know, the test is out of 10. Oh, this is the same thing from before. The mean is 6, and the standard deviation is 0.3. And again, it's normally distributed. It's normally distributed. The mean is 6. We have standard deviation of 0.3, as we can see. So now the question is, what percentage of students scored greater than 6.5? We don't want less than, we want greater than. Okay, we don't want less than, we want greater than. We can solve this though, okay? I mean, we don't have the data in front of us. I understand that. And the empirical rule is really, not going to help us too much. The empirical rule that I showed before, but that's okay. We can still solve this because we can use z-scores. I mean, you could use Desmos, I guess, to check if you want, but I really want to make sure everyone can use z-scores. So with the z-scores, first, we need the z-score that corresponds to 6.5, right? And we have done that. Oh boy. Oh, for goodness sakes. There it is. Sorry. We need to find the z-score that first corresponds to 6.5. As you can see, that's what we're doing here. Now, it's the same thing as before. Now, I'm not going to share it, but you have the table, and you have the table as well. I emailed it to you. It's also in the textbook, which is on Lumen. But basically, you'll see 1.667, as you can see. Now, again, that's not in the table. We saw that. So we had to round it to 1.7. So we rounded to 1 decimal place. In the table, what you would get is 0.9554. That's the area you would get. And let me just get rid of something. This should not be here because we don't want that because, again, we're not looking for the area to the left. Since we want greater, we want the area to the right. So we subtract, which is what we're doing here. We want the area to the right, so we subtract. So the percentage of students that scored greater than that is 4.46%. That's what happens here. Okay, this was one I was going to have you try. We're running low on time, so okay, I wanted to get to this, but let me just do this example with everyone. This one's a little bit different. I mean, basically here, you have you have more test scores. The data is normally distributed, right? Here, let me get the pen out thing. The PowerPoint pen. So the data set, right? It consists of test scores. They're out of 10. Like before, they're normally distributed. The mean is 5. The standard deviation's a half. The question is, what percentage of students got greater than 6? Well, just like before, right? What do? We have to get the z-score. Of course, I erased it. We have to get the z-score, right? We have the mean, we have the standard deviation. We have to get the z-score of 6. Now, when you do that, again, you subtract the mean, divide by the standard deviation, you get 2. All right, so let me just quickly do this, I guess. If we went to the table, right? If we went to the table, let me get to the table. Beautiful. What we would have is 2. Well, if we look at 2, that's down here, right? That's 0.9773. 0.9773. But that's to the left. It even says on the table, all values here are to the left. To the right, you do 1 minus. It says that in the table. And we want the area to the right. That's what we want, the area to the right. So the area to the left of 2 is 0.9773. We don't want that. We're going to use it, though. Well, we do want it, I guess, in a sense, but it's not the final answer. As you can see here, wait, am I able to see this? Yes, you are. Good. Didn't know if I shared this or not. Oh, come on. Darn it. No, where is it? Oh, here we go. But the air, okay, but again, we want the area to the right. So that's why we subtract. That's what we're doing here, okay? We're subtracting. So the area that we're after is 0.0227, and that percentage then is about 2.27%. So again, the area to the right is what we want. Okay, that's what we want here. All right. Okay, good. I mean, let me just what the heck? Let me start the next part. Are there any questions on this? We got a minute though. Well, basically, I'll do this next time as well, but let me at least start it. If you want to get the area between two z values, so let's say you have 2 different scores. I mean, if you have 2 different z scores, let's say, right? Z1 and Z2, they're like this. So Z1 is less than the other, right? Well, if you want to get the area between them, what I'm trying to show you here, by, by graphing, you're going to have to get the area to the left of 1 and subtract off the area to the left of the smaller. So basically here, Z2 is bigger than Z1, right? You get the area to the left of Z2 and subtract off the area to the left of Z1. I'll go over that next time because we have about 10 seconds left. So thanks for showing up, everyone. That did show up, I mean. So